From the Kennedy Space Center in Florida, this is the pre-launch news conference for CRS-20. I'm Heather Scott with NASA Communications. Final preparations are underway for the launch of a Falcon 9 rocket this evening at 11:50 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Air Force Station. The Dragon spacecraft will carry research and supplies to the International Space Station in support of expeditions 62 and 63. This is SpaceX's 20th and final resupply mission under the first Commercial Resupply Services contract for NASA. Here to discuss the mission in greater detail today are our guests, Joel Montalbano, Manager for the International Space Station Program, Jennifer Buchli, Deputy Chief Scientist for NASA's International Space Station Program, Hans Koenigsmann, SpaceX Vice President of Build and Flight Reliability, and Mike McAleenan, Launch Weather Officer with the U.S. Air Force's 45th Space Wing Weather Squadron. We'll take questions shortly, but I would first like to give our panelists an opportunity for opening remarks. Joel, we'll start with you.
All right. Well, hello and welcome again to the SpaceX 20 pre-launch press briefing. You know, every time you're about to launch a vehicle to the International Space Station, puts a smile on my face, and I'm happy to be here and happy to talk to you about this mission. As was said earlier, launch is about 10 minutes prior to midnight Eastern Time. That'll give us a berthing at approximately 7 a.m. Eastern Time on Monday. This vehicle is bringing approximately 4,300 pounds of cargo to the International Space Station, cargo that will continue our science and research program, cargo that will continue the commercialization of low Earth orbit efforts that we do on board the International Space Station, and then cargo that helps us in our technology demonstrations, work that we're doing to support the Artemis program and future exploration. The vehicle will stay on board for approximately 30 days. After 30 days, we'll return, and this vehicle will bring back approximately 3,700 pounds of cargo for our science and research cargo for our principal investigators, as well as hardware for our engineers to take a look at refurb in some cases. In addition to what we've talked about today, I'd like to remind everybody that this year we're celebrating 20 years of continuous human presence on board the International Space Station. We'll be doing that in November 2nd of this year. SpaceX has been a huge part of many of our successes. As was mentioned, this flight is the last flight completes the Cargo Resupply 1 contract. Throughout that contract, SpaceX has delivered approximately 94,000 pounds of cargo to the International Space Station. They've returned 74,000 pounds of cargo from the International Space Station. SpaceX was the first U.S. commercial provider to bring a visiting vehicle, berth it to the International Space Station, and return cargo home. SpaceX was the first U.S. commercial provider to fly mice to the International Space Station, which has been critical to the research that we've done on board. The SpaceX ISS contract was the first government contract to refly a Stage 1 booster. And throughout the 20 missions, 9 missions, we've had Dragon, the vehicle, do 2 visits to the International Space Station, and 3 of the Dragons, including the one launching tonight, will have 3 visits to the International Space Station. So huge thanks to Hans personally and to the SpaceX team for contributing to the many successes we've had on the International Space Station. We look forward to working with SpaceX on the Cargo Resupply 2 contract. We look forward to working with SpaceX on delivering crew to the International Space Station. Heather.
Thank you, Joel. And now Jennifer.
Good afternoon. It's my pleasure to be here to share with you some of the science that we'll be launching on SpaceX tonight. This Dragon spacecraft accommodates a variety of science, both within its pressurized capsule as well as its unpressurized trunk. The Dragon will launch nearly 1,400 kilograms of science, including the externals, and then we'll be bringing home about 1,200 kilograms of science when it returns. We science samples from areas as diverse as human research, biotechnology, physical science, and education. Big picture, I'd like to talk a little bit about ISS research. The International Space Station is an incredibly capable orbiting lab. Our research focus includes human research, biology, earth science, physical science, technology development, as well as education. Over the course of a year, we perform hundreds of experiments on Space Station. To date, across our partnership, we performed nearly 3,000 investigations and served over 4,000 scientists from 108 different countries. Results from these investigations help us advance areas critical to both future exploration as well as benefit life here on Earth. Under the Artemis program, NASA is returning to the lunar surface in 2024 and plans to maintain a sustained presence. What we learn on the lunar surface as well as on space station will help NASA achieve its goals for exploration. On ISS, we're learning how humans adapt to spaceflight and able to test countermeasures to keep our astronauts healthy. ISS also serves as a exploration technology testbed where we can test out and refine systems like life support systems, spacecraft materials, and coatings and things to help us design better spacecraft. Our lives here on Earth also benefit from space station research in many areas as diverse as material improvement, drug design, product stability. And if you'd like to learn more about how ISS research benefits life here on Earth, and the ISS partnership publishes something called the Benefits for Humanity 3rd edition. You can find that at nasa.gov/station benefits. I'd like to talk a little bit about highlights for this particular Dragon mission. Yesterday during the What's on Board briefing, which you can find on our YouTube channel, several scientists gave in-depth explanations of their research that's going to be flying, so I encourage you to check that out. I'd like to just mention a couple highlights in the area of tissue engineering. So tissues and cells research is a really interesting area in space. 3D structures assemble easier in space. And so this has been tissue engineering as well as organoid development has been an area of focus for us. On this particular flight, we have 2 experiments that are collaboration between the ISS National Lab and the National Institutes of Health. And the first one is engineered heart tissue. So this is looking at induced pluripotent stem cells that have been differentiated to be cardiac cells. This uses 3D tissue culture to mimic adult heart cells and a magnetic-based sensor to initiate the heartbeat of these cells as well as measure the contractile forces in a way that doesn't interfere with the growth and development of these cells. So I'm very much looking forward to the results on that experiment. The other one, again, is another tissue engineering project between the National Lab and the National Institutes of Health, and it's an organ on a chip. So this is a program that we have been doing for about 2 years now, where we have body systems that are mimicked on something about the size of a USB drive. This particular one is gut on a chip, so it models how the human intestine responds to changes in microgravity and also interacts with the circulatory system as well. We have some really interesting material science experiments flying on this Dragon. Missy 13 is one of our carriers that's flying up a variety of science. It's looking at how the harsh environment of space affects materials. Some of these are polymer and composite research, new thermal protection system for Mars and lunar sample return, as well as shear thickening fluids that can help us improve spacesuit design. So this will help make our spacesuits more resistant to punctures and tears and protect our astronauts. We have 2 new facilities coming up on this flight. One is a flow chemistry platform, which studies microgravity effects on synthetic chemical reactions. Dr. Aaron Beeler made a presentation yesterday during the What's on Board and did a really good description of that facility, so I encourage you guys to check that out if you're interested, as well as we're flying Bartolomeo, which is an ESA-sponsored external facility that will be available for commercial use and located outside of the Columbus module. To learn more about the research we're doing on ISS, both for this flight and for upcoming projects, I encourage you to follow us on Twitter at ISS_research.
Thank you, Jennifer. And now Hans.
All right, good afternoon. SpaceX is targeting an instantaneous launch window tonight at 10 minutes before midnight, 11:50, from Launch Complex 40 here. And this is the CRS-20, the 20th cargo resupply mission to the International Space Station. In the event of bad weather or any other issue, we have another backup opportunity on Saturday night at 11:27. At night, it moves basically 20 minutes every day, roughly. Late load has been concluded, 800 pounds about, and in combination, we have 4,500 pounds of both science and other supplies for the space station already loaded into Dragon. we just swung by LC-40, and we saw that the vehicle is vertical on the launch pad, ready to go, and everything looks pretty good. We're not tracking any technical issues, knock on wood, and I'm looking forward to tonight's launch. The booster supporting this launch has been previously launched on the CRS-19 mission, which was the last mission we did for CRS. And it will return to the landing zone 1 here on the range about 8.5 minutes after liftoff. Next slide, please. All right, you see 2 International Space Station badges on this Dragon, and as Joel already pointed out, this is the 3rd flight of this Dragon. We have 3 Dragons that have been reused and previously flown, and 2 of them have 3 flights each so far. This is the 3rd flight of this Dragon, and the last of the Dragon 1 flights. Let's see. I think we can go to the video. Have a quick video summarizing the accomplishments of Dragon
and
1.
the nation. It was what I call a historical event in the annals of spaceflight.
This means SpaceX's first commercial resupply mission to the International Space Station.
And liftoff of the Falcon 9 rocket and Dragon. We have another successful launch of the Falcon 9 launch vehicle carrying the Dragon spacecraft for CRS-4 resupply mission.
The first reflown Dragon is now in space.
It is great to be here with you to cover the 19th commercial resupply mission to the International Space Station for NASA.
You have a go for Dragon release on time.
Dragon release.
Yeah, this was a lot of missions. We're really proud of what we did with Dragon 1. We're also excited about Dragon 2. Beginning with next flight on CRS-21, we will be using Dragon 2, the cargo version of this spacecraft. We have 8 years of service. We spent 520 days attached to the station, and that's not counting this one. And then Joel already mentioned the number, 94,000 pounds up and 70-something thousand pounds down. That's a lot of cargo, a lot of supplies for the space station. It's a pretty major accomplishment in my opinion. Then also we basically started reusing Dragon, or using the flight-proven Dragons again, and have been able to do this for 3 times each. That's great too, and NASA has been very supportive of that and helping us a lot on that. We learned a lot on Dragon 1 spacecraft. We put all the lessons learned basically in Dragon 2 as much as we could. And Dragon 2, as you know, will be capable of flying humans, so that's basically the next evolution on our side. We also learned a lot about operations. We have been a launch provider before, a launch operator, and with Dragon we became a space operator. We have a team that is very capable of operating spacecraft, docking with the station, berthing with the station, working with NASA on a daily basis. It's really impressive. We also learned specific details, basically, like, for example, parachute is one that comes to mind. We've flown parachutes on every landing, basically. There's 5, there's 2 drogues and 3 mains on Dragon 1. And every time you use those parachutes, you learn about them. You find out, and you can have improvements for then the next generation and the next evolutionary step. We also learned from our failures, most notable from CRS-7 and CRS-2, which taught us that you have to ensure all critical components and that all critical components have to be tested as flown, primarily. CRS-2, if you recall, had a stuck check valve, and I hope I got the number of CRS-2 right, but I think it is. Had a stuck check valve, and the operational team slowly unstuck the check valve by It was basically the initial pressure that slammed this valve, and we unslammed it over time. It was very impressive and very exciting, that mission. CRS-2 lost the COPV on stage 2 at the end of the first stage burn. We had a component that held the COPV down. It had a flaw, and we didn't detect that prior to launch. And we learned the lesson there too. We got to test components in the same conditions as you fly them, and that makes the whole spacecraft a safer spacecraft. So all in all, Dragon 1 had a great career, and we're really proud on how it contributed to the important science aboard the ISS. We're grateful for NASA for their ongoing support, and we're looking forward to the continued success of Dragon. Yeah, a little bit more into tomorrow's mission. Countdown is very similar to the last missions. We will begin propellant loading at 35 minutes prior to liftoff on the first stage, and actually that always amazes me. On the second stage, we start propellant loading 16 minutes, I think, prior to liftoff. It goes really fast. And following the stage separation, Falcon 9 first stage will return to land and land on landing zone 1, while the second stage will continue to burn and deliver Dragon to orbit. The second stage shut-off and the landing is roughly at the same time, maybe by 20 seconds apart. Everything happens at the same time there. And after the second stage shuts down, Dragon will separate from Falcon 9, roughly 9 minutes, 35 seconds into flight, and then it will deploy the solar arrays 2.5 minutes later. It will berth or grappled by the station's arm on March 9 around 7 a.m. This says Eastern Standard Time. By that time, I think it's daylight savings, so that makes it 8, I think. And the rendezvous will berth with the space station, and then it will stay there for approximately 1 month. Before it comes down, it will be loaded with another 4,000 pounds of downward payload, and then land in the Pacific. I'd like to close by thanking mostly the Dragon team. This team has done incredible work over the last, more than 8 years, basically, because we started earlier, probably 10, 12 years. Did an incredible job on getting Dragon ready to fly and performing flawlessly on all these missions. And then I would like to really thank our customer, NASA, who's always supporting us, and then our partners at the Air Force, the range, and the FAA for their tremendous support. Looking forward to a successful launch tonight.
Thank you, Hans. And finally, weather is always a factor for a successful launch. So, Mike, can you tell us how tonight's forecast is looking?
Sure. We had a change in air mass since yesterday. We were flirting with the 90s yesterday, and I think we were barely flirting with the 70s today. So makes it, I guess winter's not quite done just yet. But to change that is a lot of winds. So that's really the prime factor we're looking at tonight is low-level winds for liftoff. We're going to have some pretty strong upper-level winds as well, but the winds increase gradually with height. Even though it's going to be 120 knots above us at liftoff, they do increase gradually, so I think it's going to be okay for upper level. So we'll go to the satellite picture. So you can see all those clouds move down to the south through the day. You can see a little bit what we call transverse banding overhead. That's indicative of the jet stream overhead. And again, that's what's going to be pushing that cold air, cooler air in. The winds are going to stay up through the next couple days, so it's going to be a little blustery, but I think we're going to be okay. Can we go to the forecast for the day one? So here's our forecast for tonight. Again, just very few clouds in the upper levels, just that jet cirrus probably will be around. Winds will be brushing out of the north 25 to 30 miles an hour. It is below liftoff constraints from the north, but it's pretty close. So 30 to 40% is the chance of those things kind of bumping up a little higher than forecast. They've been a little under forecast today. They've been a little bit lower than I forecast, so that bodes well. If we were probably putting out a forecast today instead of doing Crew West, we might be down to 30%. So certainly come out and check it out tonight. I also want to bring your attention to the on the right-hand side of the screen there, what we call other risk criteria. We're trying to do a better job of communicating these things that are not exact and are not local. So everything that's weather-related is not rolled into the probability violation that you see there. Some things are just not calculatable, whatever. They're not easy to do, just like saying that word. So we put those other risk criteria in there, and that's basically in a name: upper level wind shear, recovery, which is typically can occur offshore. I'll say that if this was not at landing zone 1, if this is offshore, we'd probably be a very high risk for that. Waves are 8 to 10 feet just offshore, and they'll be higher than that where they would be in recovery. So that would be a high. It's moderate because there is a landing wind constraint, but again, it's right around the same as liftoff. So I think if we can get the thing in the air, then it will land without a problem. So we'll be monitoring that. And the sun, of course, is not local or not simple, so that's another of the three things that we kind of trying to communicate to you. So again, it's just low-level winds really tonight. I think the upper-level winds look pretty good, even though they're strong. It gets there slowly, so that's the key. It's not how strong they are, it's how quick they change with height. Okay, so for backup day, if we wind up going to the next day, looks great. The clouds stay good. The winds die off a little bit. They come a little bit more easterly, so that kind of weakens them a bit. And so really just a 10% chance. I don't think we'll see much in the way of clouds. And that's just a little superstition, not to say the Z word on there. So it looks really good if we go to the backup day. So here's hoping for a good launch and a good landing, and it should be some good pictures out there. Thanks.
Thank you. Okay, we're going to open the floor to questions now here in the room as well as by phone. For those of you following on social media, please use the hashtag AskNASA to pose your question. Let's start here in the room. Please wait for the microphone to come to you. State your name and affiliation and to whom you are directing your question. And we'll start here in the front row. Second seat.
Irene Klotz with Aviation Week for Joel. Could you talk a little bit about what NASA's doing to prepare for a understaffing of U.S. crew on station, both for this handover period and then when the April launch flies, what you're planning on doing from then until commercial crew starts flying or another seat becomes available on the Soyuz, from the operations side and the science?
Okay, so we've done a couple things. The first thing we've done is we've worked with our Russian colleagues at Roscosmos to train the cosmonauts and helping us out if we have to do an emergency spacewalk, as well as the robotics to support that spacewalk. So the Russian crew members have the necessary training to help us if we have to go off in the spacewalk. We've also taken a look at what we're flying on these missions, and we're setting up so if you had something that was really intensive that required multiple crew, 2 crew members, we've kind of backed off on that, and we're flying to science that's more suitable for 1 USOS crew member. From support, we can operate the space station like this. We're good, until we're ready for the commercial crew providers to be flying. So we're good to go with the crew members we have.
I also had a question for Hans. Were there any? What was the result of the landing, the booster landing on February 17th? Why wasn't that successful? And
Right.
Were there any changes made for this flight?
Right, yeah. So at the end, we looked at that particular landing. It was Starlink 4, and the booster did not land on the drone ship. It decided at one point in time to divert and not endanger the ship. And it did that primarily because the winds that it encountered were not the winds that were predicted. Not Mike's fault at all, but I mean we rely on certain models basically, and the models indicated that the winds will shift right around the landing time. We tried to take this into account, and we were a little bit unfortunate the way we tried to estimate that, I would say. So we did some better we worked on predictive tools better. Yeah, we think we have better data in general. However, it actually does not really apply for this particular landing because it's much easier to land on the landing zone 1. It's much bigger. I don't know how many times bigger, but the ship is relatively small compared to the booster, and the landing zone is relatively large. So if you drift a little bit to the left and to the right, or north and south, that doesn't really matter in this case. And we also have much better wind prediction courtesy of Mike in this case, for this landing zone, so it makes it easier to land, and I'm not concerned for that landing because of that.
Okay, we'll take another question here in the front row in the room.
Chris Kephart with NASA Spaceflight. Wondering, since Elon and SpaceX like to put trinkets on missions to, for various things, is there anything that's not science or cargo related that SpaceX decided to put on this Dragon to link it back to the history of Dragon 1? And also for Hans, what's the exact to the second launch time?
So on the first part, nobody told me. They only tell me after the press conference. So it's a surprise. I don't think there's actually anything significant on there, frankly. It might be a picture or something like that to sign. But the number of seconds, it's 23, 50, and 31. And it's 57 on the backup day.
Okay, we'll take another question here in the room on this side. Ken?
Hi, Ken Kramer for Rocket STEM Space Up Close. For Hans, I have a question. Can you talk about the Dragon 2 cargo version, since that's coming up next? Talk about the production and the testing and manufacture of that. When is it going to be ready, and how many reflights will that be capable of?
Good question. Thank you. So Cargo Dragon 2 and Crew Dragon is very similar. The Cargo Dragon doesn't have certain parts like the escape system, and the Super Draco is basically not on the Cargo Dragon. Let's see, it has a smaller egress or life support system inside, and it also does not have the panels that are the astronaut. Obviously, it doesn't have the seats either. So all these parts are not in Cargo Dragon, and that makes Cargo Dragon a little bit bigger than the current Dragon 1, about 20% more volume at the same up mass that we currently have. Let's see, we are in the process of building it right now. I believe we are shooting for a fall launch on Cargo Dragon 2, and let's see, I think I answered your question, right? That.
How many are you building?
I don't know that. But your other question was how many times can we fly it, right? And I believe we designed it for 5 times.
Thank you.
Okay, we'll take another question here in the room. Antonia?
Hi, Antonia Jaramillo with Florida Today. My question is for Hans. Can you tell us why Falcon's booster will be landing at Landing Zone 1 instead of a drone ship? Thanks.
Yeah. It depends at the end of the day always on how much performance we have or how much performance we need for our mission and how much performance we have left for our landing. In some cases, we chose the forward landing or the landing on the drone ship because we have not enough propellant to go back. But the moment we have enough propellant to go back, the landing zone is usually our preferred choice.
Okay, another question here.
Hi, John McGill with Wyandotte Cable and News. This is for Hans. Now with the Cargo Dragon version 2, are you going to be able to autonomously dock that one?
Right. Yeah, actually, that's a good point. I didn't mention the different way in docking between Dragon 1 and Dragon 2. Dragon 1 berth, or it gets grappled by the robotic arm of the space station, and then the station basically drives it to it berthed it basically. Yeah. That door is a little bit bigger than the docking door. On the other side, if you dock it, you don't need the arm. You can use the arm for something else in the meantime. You don't depend on it. And the Demo 1 mission about a year ago demonstrated the docking of Dragon 2 very successfully. I was surprised on how fast it goes and how quick it is compared to the usual approach that we had with Dragon 1. So there's advantages to both. If you have like big pieces, then obviously you like the big door on the berthing mechanism. On the other side, if you have astronauts, you don't want the arm, and everything is less more streamlined when you use the docking port.
Okay, I'll take another question here in the front. Chris?
Okay. Irene Klotz with Aviation Week. For Hans, yesterday you all had some pretty exciting news about a contract with Axiom. Can you just talk a little bit about where you see the maturity of the Crew Dragon program, how far that will need to be developed before you would go ahead and do a commercial mission? In other words, how many operational of the NASA missions do you want to have under your belt before you would do the crew flight?
Yeah, like you said, that's brand new, basically just yesterday. I haven't really had a chance to dig into that too. If I count correctly, we have at least Demo 2, Crew 1, and possibly Crew 2. I'm not sure exactly when those missions are going to fly. I heard the year was 2021 rather, and so there's going to be a handful of other missions ahead of that, basically.
Thanks. Can you give us an update on where you are with the parachute tests for the Crew Dragon?
Yes, I would say almost done. We agreed to 3 more tests, basically, and one of them was actually performed 2 days ago. So we have 2 more tests to perform on mostly corner cases, stressing cases for the parachute. I'm pretty confident. We have an enormously large test series behind us, very successful, and I'm really excited about how we completed the parachute program and what happened, how we basically turned something that was a concern a while back into a very successful test program.
Okay, we'll take another question here in the room. You had a question, sir, on the aisle?
I have a question for Hans. Robin from Supercluster. Hans, what's the most important lesson you've learned from, I can't even see him. What's the most important lesson from Cargo Dragon that SpaceX is applying to its long-term vision of, a unifying Starship or, that infrastructure to get to the moon and Mars? What's the most important thing you've learned from Cargo Dragon?
That's a really good question. If I have to really boil it down to one thing, test as you fly, I would say. It's just, we learned so many things. We learned how to operate a spacecraft. We learned how to dock and berth with a station. We learned how to work with NASA, with Houston in parallel, how to do all these things, and how to become basically a space operator. There's so many lessons: how to recover it in the ocean, how to basically refurbish it, and how to make it safe again, safe to fly again. All of these things basically is hard to put really one thing in there. I probably think about your question a little bit and come up with one answer, but right now I would say test as you fly and just never give up on diligence and rigor in engineering. That's what you need to actually keep these programs running.
We're going to take a call now by phone. Stephen Clark, go ahead with your question.
Hi, thank you for taking my call. A couple of questions for Joel. If the Dragon launches tonight, can you give me the precise departure date planned for this mission? And also, is there any cargo in this mission going up for Doug Hurley and Bob Minkin to support their possible extended stay on the space station on the Demo 2 mission? Anything on this mission going up just to kind of keep that extended Demo 2 mission within your trade decision space? Thanks.
Okay, so on the first question, as far as duration, generally we plan about 30 days, and then that'll be based on the weather at the time as well as the science we have on board and to make sure we're complete with the science. So we've been running these missions about 30 days, so I don't have an exact date, but you can just kind of plan 30 days from berthing, and then based on the weather as well as based on the science we're doing with this particular mission, that's what we'll use to pick the landing date. As far as crew supplies on this mission, I don't believe we're flying any crew supplies for the Demo 2 crew.
Okay, we'll take a question here in the room back there.
We have a question from Twitter. This one is for Hans. What will happen to the capsule after it returns to Earth?
What would happen to the capsule when it returns to Earth? We will recover it, put it on the boat, bring it back into the harbor, unload it, hand over all the cargo to NASA, and then think about what we're going to do with that capsule. It's a good question, actually.
Okay, we'll take another question here in the room on the aisles, if we can.
Journal of the San Juans. This is for Hans. After 5 uses, will you throw away the whole airframe and motor, or can the motor be replaced and the airframe continue to be used?
In terms, you're talking Dragon 2, basically,
yeah,
right?
Dragon, yeah.
So I think that's a little bit complicated in that sense, because when you say motor, do you mean the Super Dracos? If we run Super Draco ever in terms of an escape or something like that, then I'm not sure if we can use that capsule again without serious refurbishment. Yeah, when you talk about the Dracos on the other side, those have a much longer lifetime. So, to be fair, all these the number 5 right now is a design number. A lot of that depends on what you actually see when you come back. Whether you find corrosion or whether you find wear and tear, and all these things are right now engineered. In reality, we might be able to run the capsule 6 times or 4 times, depending on what we find. So I would probably wait till then. And we also learn in our refurbishment programs, both on Dragon and on Falcon, which parts have to be exchanged and which part can live longer than we expected them to live. So it's a lot of learning experience to refurbish spacecraft.
Follow up, if I could. How much payload would you gain if you configured this chip to be single use?
I don't think there's more payload in that, frankly.
Okay. I'm just assuming there's some fuel and mechanisms that are being used to reland it that you could...
You may... So, okay, let's see. Engineering principles, right? I mean, you design things a little bit sturdier for 5 launches or for even 10 launches or 20 launches, yeah. But I believe between... That in itself is probably not that much. So I really don't think it's going to be much of a difference.
Okay, we'll take another question here in the room in the front.
Kirby Kaler, Sky News Canada. Are there any plans for the ISS to be able to dock more than one spacecraft at a time?
What we're going to do is once we're flying the commercial crew program, we'll be docking 2 vehicles at the same time, where you'll have what you call a direct handover. Well, one vehicle will come up and stay for about 6 months. The next vehicle will come up before that vehicle leaves. There'll be a short handover. So at that time, you'll have 2 vehicles docked to the International Space Station.
Will there be plans for more after that?
Right now, we just have 2 docking ports, and I'm talking USOS vehicles. We still have the ports on the Russian side, so you'll have a Soyuz docked to the spacecraft as well as a Progress vehicles. And so, but from a USOS, just 2 at a time.
Thank you.
Okay, we'll take a question by phone. We have Chibeli Carzano with Orlando Sentinel. Go ahead with your question.
Hi, thanks so much for doing this, everyone. For Hans, I was wondering, we got an update today from Boeing about how they're handling some of their testing going forward due to the anomalies they experienced with Starliner, and there was some discussion about whether there's going to be spillover to the other programs. I'm wondering what SpaceX's testing process usually look like, and have you heard from NASA about sort of reevaluating what you all do with Crew Dragon? Thanks a lot.
Okay, so if I heard you right, you're asking what are we doing for software testing, and if I heard from NASA too, I didn't really catch that. But let me okay, here it is. Here, let me answer your first question. Basically, we test software a lot. We have actually something that's called a hardware in the loop simulator, and it's basically it's a table full of all the components that are on Dragon, another table with all the components that are in Falcon, and then there's a really elaborate computer that basically plugs into certain parts on the Falcon side and records certain parts on the output. So, for example, if you imagine that you would simulate what the IMU or the gyro basically measures and the GPS measures, and you would record what the thrust vector control on the rocket basically does, yeah, and you run this. In this case, it's relatively easy. It takes 10 minutes. It runs in real time. Yeah, so you can basically run this every 10 minutes, and that's actually what we do. Yeah, so we have a system set up that whenever you make a change on software, it runs through a certain system of tests, and it also does this particular test, which we call hardware in the loop or HIDL. Yeah. You got to be super careful that you do this test right. You actually got to look at gaps, and for example, you could have an error in the polarity of the IMU, both on the real, on your simulated IMU in the computer and on the IMU that you have on your table. So in that case, we actually do a test on the actual spacecraft. We move the IMU and we test that everything is connected properly. That's how you fill all those test gaps. And then last but not least, there are certain things like calibration that you have to review. There's a very elaborate system that reviews data, that reviews configuration files and makes sure that they are signed off and that there's a proper paper trail to all the way down to the sensor information that we get from the vendor or that we get from our own acceptance tests. And all that together, last but not least, there's also something that's called a unit test, where you test a function in software every time you basically compile this piece of software. So it tells you basically this function is still working like it used to work. That's a way to actually find when you break components early, and it allows you to really test quicker and to test also better. And all of this together basically is our approach to software. And it's I cannot imagine a better approach. I cannot imagine an approach that tests more. We test basically continuously, and in my opinion, that is an excellent way of testing even complicated software, which in my opinion should be tested even more carefully.
Okay, we'll come back in the room. Kristen?
Chris Gebert with NASA Spaceflight with two for Hans. The first one, because you were talking about the testing and always going forward and the design iterations. A couple of CRS cargo flights ago, there was the second stage that had a little gray stripe on it, and it was testing something with thermal conditioning of the propellants. Just curious, how did that go, since we haven't seen it reappear?
It's a good question. I think that this particular gray part was on the fuel tank, and we wanted to test if we can keep the fuel at the right temperature for a long duration mission. I believe it worked as we wanted it to. We only going to do this if you have a really long duration mission on the second stage. So for example, if you do like a couple hours of coast and then do another burn, that's what this is basically good for. For normal missions, or the duration is relatively short on the second stage, typically 45 minutes for the second burn, and then maybe another 40-50 minutes for the orbit burn. So these are very specific and special missions that we test that for. And from what I remember from the data review, it went all well.
And the follow-up, for Dragon 2, do you guys have the capability to fly more of them at one time in orbit?
Yeah, like Joe pointed out, we almost have to. Yeah? I mean, there's the handover on the station, and there might also be cargo missions going on the same time. So in our vision, there's going to be 3, maybe 4 at the same time, right? So we certainly have the ability to do that and the capability.
Okay, we have time for just a few more questions. We'll go here over to the right side.
John McGill with Wyandotte Cable and News. This is for Hans. Hans, with the Dragon 2, now it's my understanding that that's going to be launched at 39A. Now, will it still be able to launch at Slick 40 if need be?
Good. It's a good question. So Crew Dragon launches from 39A. It doesn't need the launch tower and the bridge, the walkway over to the capsule, obviously. On Cargo Dragon, we have typically a device that performs the late load, and we have more flexibility there. I'm not sure if you plan to launch from both, but I don't see a particular problem not to do that, frankly. So it depends a little bit on what GSE or ground support equipment, rather, we use for the late load there.
Okay, down here in front.
Irene Klotz, Aviation Week. I was just curious. I know you got to 3 on the Dragon 1, but what was the design of Dragon 1 initially for reusability, and how many vehicles do you have? And I know you're deciding what to do with them all, but how many actually are you going to be distributing?
I have no idea where they all are. But I also haven't really looked for them. Yeah, I mean, there's going to be, I don't know, maybe museums or something. California Science Center, my favorite.
Like one.
Yeah, so I think we store them right now in Texas, but I have no details on where they are.
How long were they initially designed? How many flights were they initially designed for?
I don't remember that. It's been very long, right? I mean, after all, that's been designed, 12 years ago. I believe it was 3 times at that time. So we pretty much did what we wanted to do. We didn't do this on the first couple of capsules. Yeah, we needed to learn a little bit on how to waterproof Dragon first. And like I said, there's always this learning factor when you go into refurbishment, and it takes you a little bit of time and to work this out. But at the end, it runs very smoothly.
Okay, we're going to go back to the phones. We have Stephen Clark again with Spaceflight Now.
Hi, I have a weather question for Mike, or maybe Hans has the answer. What's the wind limit for ground winds for a Falcon 9? I understand it may be dependent on direction, but from the north tonight, what's the limit we're looking at?
So I'm not sure I understand the question.
Liftoff. He's looking for liftoff criteria.
Oh,
the limit.
On the lift, it does depend on the direction. But I want to say that's almost in the details. It's like a couple of miles per hour, depending on the direction. But in general, it's above what we have right now. It's above 30. No, it's above 30. I don't know the exact number. I think it's 34, 35, something like that.
Okay,
It does depend on the direction, indeed.
We have another question on the phone. We have Bill Harwood with CBS News. Go ahead, Bill.
Yeah, thanks. Quick question for Joel. Assuming that the Soyuz goes up on time and this spacecraft gets up there on time, are you still thinking about an EVA during handover to hook up Bartolomeo, or is there other issues there that might rule that out?
Nope. The current plan is to continue as we've been advertising, that we'll do a spacewalk during the Soyuz mission.
Y'all have a target date for that?
Okay, we have time for one final question here in the room.
Yeah, I don't have the date. I can get that for you, and we'll get that sent to you.
Okay, final question here in the front.
Hey, Ken Kramer, Rocket STEM. For Hans, can you give us your perspective on the upper level winds, how close we are?
So it's interesting. I have to be technical. It's not just the upper level wind speed that's important. It's the wind shear that's important. And also, it's the prediction of shear. So it's basically, if the prediction is good, then we can actually fly through a fairly high shear because we steer the rocket basically accordingly. If the prediction is not good, then we might have a problem. And we check that by launching balloons and verifying this with some final simulation runs, that everything is okay. So in terms of today, I have not looked at it in detail. That is one of the next things I do in the next couple of hours. But I've heard that the upper level winds are not as traumatic. And what I then care more is that they are really predictable and not changing over the next, I want to say 7 hours, basically. That's important.
Okay.
He's nodding, so I think they are predictable.
Okay, that's all the time that we have for today's news conference. As a reminder, our live launch coverage begins at 11:30 p.m. this evening on NASA TV, as well as nasa.gov/live. You can also follow mission activities at nasa.gov/station and nasa.gov/SpaceX. Thank you again for joining us today. Until next time.